Hey guys, this is Karan here. In this section we'll be talking about gravity. So what is gravity? Whenever you have an object, then whenever you throw an object, why does it go down? Why doesn't it just float? Have you ever wondered why? Well, the reason is because of gravity. Well, now here we're not going to talk about gravity because we already know what gravity is. We're here because we need to know why the gravity is equal to 9.81 Newton over kg. We need to know the reason. Most people or most textbooks just give you that the gravity is this number and they never show why. But the reason is because it's so complex and people are not able to teach that thing to their students or discuss it with their colleagues. Now in this section or in this video we'll be talking about why that number or how the gravity is being derived. So in order to do this we need to use the Newton's the law of universal gravitational formula in order to determine the gravity of Earth. Now the formula basically looks like this. The formula says mass times and don't mistake G with the gravity, because G is the mass of the Earth, okay, which is equal to gravitational force times mass 1 times mass 2 all over radius squared. So there's two things that is going on that we need to find. The first one is the mass of the planet that we are talking about and the radius of that planet. So we know that G represents the mass of the planet. And here, which planet are we talking about? Well, the gravity is on Earth, right? So we'll be talking about the mass of Earth. And since we are using the mass of Earth, we will also say that R represents the radius of Earth. Now you can find this two pieces of information from Google or from a textbook of astronomy or any other textbook that you can find these details in. Now if we go back to the formula, we have mass over here and two masses right here. Now what we can do is basically divide off mass on both sides and cancel each one out. So what happens is this mass cancels out with mass 2, so we don't really need the mass 2, okay? So here the basic formula now would look like the mass of the Earth would be equal to gravitational force times mass 1 divided by radius squared. And now what we are doing, basically solving for the gravity, right? So the gravity would be, now it would be equal to G is equal to the gravitational force to 6.67 times 10 raised to negative 11 times the mass of the Earth would be 5.98 times 10 raised to 24 kg. And you divide that by the radius, and notice it's being squared, don't forget that. So the radius would be 6.37 times 10 raised to the 6th power meter, and you need to square that. So after you do this, what you end up is basically with your answer, which is gravity on Earth is equal to 9.82 approximately. This is rounded, okay? So there is 9.8182, something like that, goes on forever and ever. Okay, so here would be Newton over kg. So this, my friends, is how the gravity is being derived. And notice that we said the mass of the Earth would be represented by G. But do recall that G is always in physics used for the gravity. So here, even though it's saying that G is equal to mass of the Earth, don't be confused that I have mistaken on writing. I should have written the mass of the earth right here, because at the end of the day we are finding the g, in which other formulas, if you look, g always represents the gravity. And it's dependent upon which planet are you talking about. Here, since we are talking about Earth, we say mass of Earth would be represented by g. But what I did was, instead of putting this value here, I plugged in with the mass 1, which is the mass of the Earth. Okay? So this is how I derived the gravity which is on Earth. And you can find the gravity of any other planet simply by plugging in the mass of that planet and the radius of that planet, and you have to square this as well. This remains constant as the gravitational force remains constant.